So in this talk, we're going to discuss combining like terms. So this is where if we have some messy expression, you want to kind of, as much as possible, simplify it down and put things that look the same together. So if we look at this first expression here, we got some stuff that involves a root 5, some stuff that involves the variable x, and we got this square root of 49 as well. Okay, so how can I simplify this as nice as possible? So something that looks reasonable. So what we want to do is kind of figure out, well, which pieces can go together, which of these things play nice together. So, okay, the 7 root 5, there's not all that much I could do. Sometimes you just want to do the more basic arithmetic first before you even do this step. Here I have a 9 times 2. So when I multiply 9 times 2, I get 18. So I get a 7 root 5 minus 18. This 3x, I can't really simplify it more. This 4 root 5, I can't really simplify that a whole lot more. But this root 49, before I start grouping things together, I might be able to say here, well, what is the square root of 49? Well, I know that 7 times 7, if I just think about our multiplication table, is going to be 49. So this thing here is just going to be plus 7, which is a whole lot nicer to look at than some ugly square root. Okay, so now here's where we start grouping like terms. Here I got something with a root 5. I have another thing with a root 5. And when I combine those two things, 7 root 5s minus 4 root 5s are going to combine and give me 3 times the square root of 5. Now, I have a few things that are constants or that are just numbers that don't have an x nor square root of anything in it. So minus 18 plus 7 are going to combine to give me a minus 11. And I have this plus 3x. There's not all that much I can do with it, so I'm just going to have it plus 3x. It doesn't particularly matter which order you have these things. Again, you need the minus in front of an 11, but you could have negative 11 plus 3 times the square root of 5 plus 3x or something like that. But notice what we've done, though, is we don't have kind of multiple things that I could put together. So this is a nicer expression for a grader, say, to look at, or if you have to type things in, this takes a lot more work here to type into a computer. So when we look at this mess we have down here, there's a lot of pieces going on. I got square root twos, I got square root of threes, I got some just regular old fun-filled integers. But if I want to simplify this up, we might need to distribute. We might need to expand everything out before we do that. So this 3 here is going to need to get multiplied by both this term 2 and this term 3 root 3. So 3 times 2 is going to give me 6. 3 times 3 times root 3 is going to give me 9 of these root 3s. Okay. Now, here I have something that has a 1 plus root 2, and then I'm multiplying it by 5 minus root 2 plus root 3. Now, there's not some FOIL equivalent here. So when we need the distributive property, we need to multiply 1 by 5. We need to multiply 1 by the square root of 2, or negative the square root of 2. And we need to multiply 1 by root 3. So this 1 times 5 is going to give me 5. My 1 times negative root 2 is going to give me a minus root 2. And my 1 times positive root 3 is going to give me a plus root 3. Okay. But I also had this other piece over here that I had this root 2 that it also needs to get multiplied by all 3 things in this second set of parentheses. So I need to have the square root 2 times a 5. Well, so that's 5 root 2. But when I look at these next two things, I'm going to need to use one extra property of the square root function. So we happen to have that, the square root of x times the square root of y is the square root of x times y. And we can talk more about square roots and exponents in another week. But so when we're kind of following this pattern, so I have this 2 times negative root 2. So this root 2 times minus root 2. Well, okay, so I have a negative that's kind of hanging out, but I have a minus root 2 times root 2. And if I use this pattern here, this would be the same thing as minus square root of 2 times 2, or minus the square root of 4, and that's going to give me minus 2. So from this, we end up getting a minus 2. So square root of 2 times negative square root of 2 gives me just 2. We also could figure out what to do with the square root of 2 times the square root of 3. It's not really going to clean up all that much, but we could group everything together inside of a single square root and get the square root of 6. So from the square root of 2 times plus the square root of 3, I get plus root 6. Okay, so now I have a bunch of different terms, right? But now we're in good shape because we can start grouping things together. So for instance, I got some things that involve root 2s, I got some things that involve root 6s, and I got some things that involve root 3s, and then I also have some things that don't have any square roots in them at all. So for instance, I have this 6 here and this negative 2. Those are, and I guess I also have this 5. Those are the three things that don't have a square root of anything involved in them. So I can group them together. 6 plus 5 take away 2 is going to leave me just with 9. Okay, good, good, good. I also have some stuff with root 3s. I have 9 root 3 plus another root 3. So I have 9 of these root 3s plus an extra root 3 are going to give me 10 root 3s. What else do I have that I haven't kind of dealt with yet? I have some stuff involving I have some stuff involving root 2s. So I got minus square root of 2 and plus 5 root 2. So I got negative root 2 plus 5 root 2. So I got minus 1 plus 5 of these root 2s. So I get a total of plus 4 times the square root of 2. And last but not least, kind of hanging out over here, I got this square root of 6. And it doesn't really play nice with anything else, so it's just there. And again, we've grouped now everything together as much as we can to kind of make a nice compact answer.